Hello, this is question 21 on your mix exercise 3 from the other team. You have to sketch the graph of y equals absolute value of 2x plus a when a is a positive constant showing the coordinates of the points where the graph meets the coordinate axis. So this one, if you consider the straight line, the straight line is going to be positive gradient and positive y-intercept, so it's going to be a line here, more or less. Well, the gradient is more than one, so let's going to do it a bit more slanted. So this y-intercept is going to be a. Yeah, I'm representing the line without the absolute value. When we apply the absolute value, we will get that everything that is below the x-axis will be above the x-axis. So our line is doing something like this. Yeah, and so we don't need to represent this. I just did it for being able to represent the graph. The x-intercept, or the point where the x cuts the axis, is when y is 0 in this function. So if I make, when I have this function, if I make a y 0, I have 2x plus a, which means x is minus a half. So this point here is minus a halves. Yeah, and that's the graph of absolute value of 2x plus a. Then on the same axis, sketch the graph of y 1 over x, which is a reciprocal graph. So we are going to represent another function. It's going to be in this quadrant, and in this quadrant, remember, is 1 over x, so we know how to represent that. Explain how your graph show that there is only one solution of this equation. This equation, if we reorganize a tiny bit, we have, so we are doing C, that was for A. We have x, absolute value of 2x plus a minus 1 equal to 0, which means x, absolute value of 2x plus 1 is equal to 1, and divided by x, we have 2x plus a is 1 over x. This equation is the same than this one, and this one is giving me the intersection between this graph and this graph. Remember how we find intersection between two lines? We just equate the y's to each other, yeah? So this line or this graph is this one, is the blue one, this one is the pink one, and our graph is telling us that there is only one point of intersection between them two, yeah? Only this point here. So that's how the graph shows that there is only one solution to this equation, because this equation represents the intersection between this pink line and this blue one. Yeah? Then find, using algebra, the value of x that satisfies the equation. So let's go to solve the equation. We know from here, so this is the original branch of our line, and this is the mirror one. So this part of the branch is going to be the one positive, so just 2x plus a. Yeah, the other one will be with a minus at the front. So really the one that we can use to find this intersection is going to be this one, intersection with this one. So we are going to use the positive equal to 1 over x. And then we are going to solve this equation. This equation is a quadratic. When I multiply everything by x, I have 2x squared plus ax equals to 1, which means 2x squared plus ax minus 1 is 0. And using the quadratic formula, we have that x is going to be minus b, remember, plus minus square root discriminant divided by 2a. When we substitute each of the values, minus b is minus a, plus minus b squared is going to be a squared, minus 4 times 2 times minus 1 becomes positive, and 4 times 2 is 8, so a squared plus 8, divided by 2a, so 4. This gives me two solutions, because I'm doing the intersection of this line, the whole line, with the pink. Yeah, so we will have one point of intersection here and one point of intersection here. So the one that we are looking for is the positive one. So our solution would be x and just the positive one. So plus root of a squared plus 8 divided by 4. Yeah, and that's all with this question.